Yo 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 yo. Okay, today we are going to talk about, or in this video, I should say, we're going to talk about angle similarity with triangles, and we're going to use this to find unknown measurements of side lengths of triangles, or maybe even of angles. So I'd say here's your key terms. Similar figures we've actually already talked about. And similar with triangles is the part that's a little bit new, but we'll get into it once we actually start looking at some problems. So basically, angle similarity means if two angles of one triangle are the same or are congruent to two angles of another triangle, then the triangles are similar. So we're trying to figure out if the angles are the same. If two are the same, that means all three of them have to be the same, because they're going to add up to 180. So if at least two of them are the same, then all three of them are the same, which means that they are similar. So that means they're the same exact shape of a triangle, they just might be different sizes. So if you want to determine if two triangles are similar, we just have to compare their angles. Like this one has a 100-degree angle and a 45-degree angle. This one has a 100-degree angle and a 35-degree angle. Well, these two don't necessarily match. The 100 matches, so that's good. But the 35 and the 45 don't match. But this might be a 35 and this might be a 45. I don't know. So what I need to do is I need to figure out, well, what is this third angle on these triangles? In one of these triangles, I should say. So if I were to add up 145, I get 145. Well, I know that all three angles have to add up to 180. So if I do 180 minus 145, I do get 35. So that means this is a 35-degree angle. So now I know they both have 100 degrees in common and they both have 35 degrees in common. That means this is automatically a 45-degree angle, which means that these are similar. Oops, not working. Weird. Pen stopped working. But there we go. These are similar triangles. So they're the exact same shaped triangle, they just might be different sizes. So now what we're also going to do is we're going to look at similar triangles to find missing side lengths. So while playing tennis, Matt is 12 meters from the net. So here's the net right here, which is 0.9 meters high. He needs to hit the ball so that it clears the net and lands 6 meters beyond the base of the net. At what height should he hit the ball? So we're trying to figure out what is this side length right here. I'm trying to figure out how tall is this side. So I want to know what this side length is. What I'm looking for is two similar triangles, because once we know we have two similar triangles, their side lengths are proportional. So here's what I mean by that. If we look here, oh, that was me trying to trace and me missing. Okay, so if we look here, here I have a triangle. This is a right triangle. Man, the pen is sometimes working and it's sometimes not. So let me just use my mouse. So here's a right triangle. I'm going to redraw that right triangle over here. Now with this right triangle, I know that this side length is 0.9 and I know that this side length is 6. Okay. Now I also have a lot bigger triangle here. I'm going to draw it in purple. I have the whole entire thing. This is also a right triangle. So this whole entire triangle is a right triangle. So we're going to draw the purple one over here. I don't know what this side length, that's what I'm trying to find. But what I do know is I do know this whole side, because this side from here to here is 12, but from here to here is 6. So this whole side is 18. So what I know is I know that these are similar triangles, and the reason why I know that is because of angle similarity. They both have this right angle in common right here, but then they also, this angle right here is also the same. And the reason why is because these are parallel lines. They both go at a right angle, right? So these are parallel lines, and this would be a transversal that goes across those two parallel lines. So these are corresponding angles, which means these are the exact same angle. And then we also know that this is the same angle, because doesn't this end at the same spot? Yeah, so this is the same angle as well. So they have the same angles. They're just different size triangles. So they're the exact same shape, different sizes. So because of that, their side lengths are proportional. So what I can do is I can set up a ratio to compare the side lengths. So if I'm looking at just the bottom sides, okay, the bottom sides right here, I am comparing these side lengths, and really what I did is I took this 6 and I multiplied it by 3, and that got me to 18. So this triangle is 3 times the size of this triangle, which means I can take this side length and also multiply it by 3 to get 2.7 meters. And I am done. So because this triangle is 3 times the side, and I know that because 6 times 3 is 18, that means this triangle, I can multiply each side length by 3, and that's going to give me all the side lengths because this triangle is proportional to this one because they're the exact same triangle. So all I did is I realized that this was 3 times the size, so I multiplied both sides by 3 to figure out what the height is. We'll do another one. Okay, so now we have a similar thing. We know the full length, we know the smaller length, we are looking for this height, and we have this height. Okay, so what I can do is there's really 2 ways to set this up. So again, we have the smaller triangle and we have the larger triangle. So the smaller triangle, if you need to redraw the triangles to help you see it, you can. So the smaller one, I know that this is 8, I'm trying to find this side. The larger triangle, we'll do this one in purple, it's the whole triangle, and I'm sorry my tracing's so bad. I'm struggling on the mouse today because the pen's is not working. So that's 2, and we know this whole side is 24 because it gives us these lines that goes from both. Okay, so we know these are similar triangles. They share this angle on the end. These are corresponding. We know that these are both right angles. So these are similar triangles. So what I know, one way I can set this up is I know that I can set up one triangle over the other. So I can set up the side lengths over the other. So this bottom and this bottom part of the triangle are proportional. So I could set that up as 24 over 8. And then I can set that equal to, I have to keep the same triangle on top and the same triangle on the bottom. So because the bigger triangle was on top, that'd be 2, because I'm looking at this side length, over this side length over here, which is x. So I'm trying to figure out, and this is the way we would solve it if we don't know exactly how to, if we don't know exactly what we're multiplying this by to get to here, or what we're dividing this by to get to here. So now what I can do is I can actually do some cross multiplying. I can do 24x is equal to 8 times 2. So this when we cross multiply, I multiply diagonally, 24 times x is 24x, 8 times 2, and then that's actually 16, so I'm going to divide both sides by 24, and that gives me x equals 16 over 24, which does simplify if I divide these both by 8 to 2/3. So that means this height right here is equal to 2/3. Now another way I could have done that, some of you might have been able to see that, to get from here to here, the reason I'm looking to see if I can go this direction is because this is the one I'm trying to find. So this is one way to do it. This way will work every single time. But another way I could have done it, if we're fairly good with our multiplication facts or division facts, I know to get from 24 to 8 if I had divided this by 3. 24 divided by 3, ignore this little dot right here, 24 divided by 3 is 8. So that means I would have had to divide 2 by 3. Well, 2 divided by 3, another way to write that is just 2/3. So this is 2 divided by 3. Okay. So go ahead and do these 2 on your own. Explain whether the triangles are similar. So are these 2 triangles similar, yes or no? Positive if you haven't done so. Try it, see how you do. Well, they have these 70-degree angles in common. 58 is not 49, so I got to figure out what this last angle is over here. Or I got to figure out what this last angle is over here. So I can do 70 plus 49, which is 119. So now I got to do 180 minus 119. I got to get 58 for them to be similar. And it's definitely not 58. It is 61. So that means this is a 61-degree angle. So they only have one angle in common, so these two angles are totally different, so therefore not similar. Okie dokie. That's it, guys. So we won't put anything in the things to remember today. Independent practice, here you go, give it a shot. You have your two triangles. There's a small one, and then there's the large one. And then let's see how you do with the heights or the extension, okay? All right, guys, that's it. If you guys need any help or have any questions, let me know. Thanks for watching. Good to see you out.